So notice it says find the derivative of y with respect to x. This is important. You want to pay attention to this variable. The independent variable in the denominator there is telling you what you're differentiating with respect to. Why is that important? Well, because the very first step, you're going to have to take d dx of both sides, so that in the end you end up with finding what you need, dy dx. Yes. Okay, so we're going to take the derivative with respect to x of both sides. Let's go ahead and on the left, let's break that up into two different derivatives, right? The derivative of each part. So d dx of x cubed y cubed minus d dx of y. But what's d dx of x? 1. Okay, so that one's done at least. All right, now the d dx of y is just going to be dy dx. That one's easy. But this one here, what makes this one a little bit more challenging? Product rule. That's right. We cannot just take the derivative of x cubed and the derivative of y cubed and be done with it. We have to use the product rule. So this is going to be x cubed is going to be our first function. Y cubed is going to be our second. We're going to have first times derivative of the second plus the second times derivative of the first. So first function is x cubed, and we want to multiply that times the derivative with respect to x of the second function, y cubed, plus the second function's y cubed, and we want to multiply that times derivative with respect to x of x cubed. If you don't need to write out this step, that's great. I'm just trying to make it clear where everything's coming from. Okay, so this is going to be x cubed times, you tell me, what's d dx of y cubed going to be? Very good. 3y squared dy dx. Why? Because we apply the power rule as if that were an x. So we bring the power out front and subtract 1 from it. But to compensate for the fact that that was not an x, we then have to multiply times the derivative of the base. He said every time you take the derivative of a y, you're going to end up with dy dx, and that's true. When you're differentiating with respect to x. Okay? All right, now we have y cubed times, what's the derivative of x cubed with respect to x? Just 3x squared. We don't need to multiply times the derivative of x. It's just going to end up being 1 anyway. Minus dy dx equals 1. Okay, so let's just pause for a moment because we have differentiated. Okay, why is that not our answer? What were we actually asked to find? dy dx. dy dx equals something. How do we find that? You're going to have to arrange it so that you get all the terms, things that are being multiplied. Get all the terms to one side that have the variable in it you're looking for, all the other terms to the other side, right? So what do we have? We have 3x cubed y squared dy dx minus dy dx, and I'm going to move this other term over to the other side, equals 1 minus 3x squared y cubed. Since it appears twice, you have to do that little trick you may remember from algebra where you actually factor it out, so that it now only appears once. Oops. So you're going to have dy dx times 3x cubed y squared minus 1, good, equals 1 minus 3x squared y cubed. And then we're going to divide to get dy dx by itself. So you're pretty much going to repeat that procedure frequently when you're working these problems. Get the dy dx's to one side, everything else to the other, factor it out, and divide. So now we're done. Notice that our derivative formula has x's and y's in it this time. That's to be expected. There's nothing you can do about that.
I hope you found this video useful. If you did, please remember to like it.